multiplication. All right, multiplication is really just, let's look at this. So something like 4 times 2, right? Well, multiplication is a simplified form of addition, because remember how I said those old math nerds, they like ways of simplifying things so that you don't have to do stuff over and over and over. Well, that's what multiplication is. It's like saying we got 4 groups of 2, so it used to be 2 plus 2 plus 2 plus 2 is what you'd have. And they said, well, we hate this. We hate writing this all the time. So they came up with this multiplication stuff. But that's what it is. The first number right here tells us how many, usually they say groups, how many groups of this second number right here. So that'd be how many groups of 2. In this case, 4 groups of 2. So we'd get 2, 4, 6, 8. And we can see that that would be 8. Same with the addition part on that, okay? So 2 plus 2 plus 2 plus, I think that was 4 2s, is 8. Or 4 times 2 is 8. They're the same thing. So we got exponents and order of operations. Let's check this stuff out. So the first part, let's look at exponents. Exponents, by the way, are kind of their own. Spelling's hard sometimes. Exponents. Yeah, that's good. Exponents are just another one of the 4 major operations. But here's what happened is, a long time ago, math people, math nerds, whatever you want to say, let's not use X. Let's use something like 2. So they would multiply 2 over and over and over, maybe even 10 or something like that, but 2 is easier to write. And they got tired of this garbage, so they said, we need to write a different way. We need a different way to write this so that we don't have to write 2's all this stinking time. So what did they do? Well, well anyways, we got this exponent stuff. So they said, instead of writing 2 over and over and over, we're multiplying 2 over and over. That's true. But how many times did we multiply it? 1, 2, 3, 4, 5, 6, 7, 8 times. So they created this little number here in the top right corner of the number to indicate that we've multiplied 2 by itself 8 times. And after that, they rejoiced and they ate some cupcakes. So that's why exponents are really nice, because instead of having to write stuff over and over and over like they used to, now they've given us a shortcut, and everyone feels like it's important for you to know. So that is exponents. Well, then we got this order of operations stuff. Order. And this is commonly referred to as Pemdas. And each of these represents a word. So I think they call those acronyms. So P is for parenthesis. And yes, whether I spell this right or not, please know that I'm trying my best. Parentheses. Well, parentheses include stuff that looks like this. We'll look at some that look like this as well. You don't have to know what those are yet. We'll talk about it. But these are the 2 major ones. Sometimes they'll show brackets like this just to separate the different types of parts of the problems. And then we got this exponent stuff. So now we got exponents. And then we got M, which is for multiplication. And D is for division here. Now the reason I'm using the same color for these is because it doesn't matter which one comes first. If division is first, then we do that. So it could be Pemdas. You see what I'm saying? So we could change that order there. But it's always from left to right. From left to right. Then we got the A, which is addition, and S is subtraction. But this again is from left to right. So addition or subtraction from left to right. So you will have to memorize this order, okay? Now, I'm not saying this just because we're in a medical type room, but I like to compare it to operating. I've had an operation before where they had to knock me out, you know what I'm saying? But it'd be really freaky if they just started cutting you open without the anesthesia, you know what I'm saying? So there's an order for being operated on, and it's the same way with math problems. If you're going to operate on a math problem, I mean, if you don't want to get sued by the math, then do it in order, okay? Otherwise, you'll have a screaming patient, and we'll have to mark it wrong. So don't do it, okay? Do it in order, parentheses, exponents, multiplication or division, addition or subtraction. All right, so here we have 4 to the power of 3, and we want to evaluate this, okay? Actually, so this is 4 times 3, right? I'm sorry, this is 4 to the power of 3. So I'm going to rewrite this. So it's kind of like what we had before, but instead of changing it from an expanded form to an exponential form, let's expand this. So what is the number that we're being multiplied together all the time in this one? 4, right? And how many times are we going to multiply 4 by itself? 3 times. So 4 times 4 times 4. Now the order of operations, this one's pretty easy because there's no parentheses. We got rid of the exponent, and we can see that the exponent really is just multiplication. So from left to right, let's look at this. Now I like to show it with this little V thing like this, okay? So in other words, I'm going to do this 4 times this 4 right here first. Okay? Now that would be 4 plus 4 plus 4 plus 4, or 4 groups of 4, right? And you can count if you needed to. I think there's songs for this kind of stuff. I'm not that creative, so 4, 8, 12, 16. So I got 16. But then I still got this 4 right here, right? So I need to multiply the 16 by 4. Well, that would be 16 groups of 4. That's a little bit more difficult on this. So what we can do is we can split the 16 up into 10 and a 6 and 4. Now the reason I'm showing you this is because if it's easier for you to do it this way, then do it. If not, we'll show you other ways to do it as well. So if I had, this is saying that I got 4 groups of 10 and 4 groups of 6. Yeah, that sounds better to me. So if I had 4 groups of 10, what would I have? 40, right? 10, 20, 30, 40. Well, if I had 4 groups of 6, what would I have there? 4, 8, 12, 16, 20, 24. So we're going to add these two together. And if it helps you to do this vertically, because that's sometimes what we're just used to, 40 plus 24. You guys remember seeing this a little bit? Maybe. So we're going to add these by the place values. So in the ones position, I got a 0 and a 4. 0 plus 4 is 4. And then I'm moving to the tens position. 4 plus 2 is 6. And that would be our answer for this thing, 64. Now, even though we can't use a calculator on this first test, I still recommend that you at least use it to check when you're doing the homework, okay? So it's not like it's been completely banned. You just can't do it on the test. Does that make sense? All right. Is there any of you guys that would have multiplied this vertically? So 16 times 4, like this. And that's okay. All right. So the way that I showed is very uncommon. I only do that to show you a different technique. And so I do not require that you guys do it a very specific way. You choose the way that works best for you, and then go with that, okay? By the way, this is the same thing, so, right? Because you'd get 24 and then 60, which is 60. No, that's not 60, dang it. 40, that's better, which is 64. All right, so the order of operations, I don't see any parentheses here. I don't see any exponents. Do you guys see any multiplication or division from left to right? Yes. Yes, we should. So we've got this 12 divided by 3. So let's look at this, okay? Division. So how many times does 3 go into 12? Maybe you guys remember this long division stuff, okay? Well, this is 12 divided by 3, which is actually a little bit backwards, but long division works that way, I'm sorry. I didn't make the rules. Some really famous nerd back in the day did. So we look at this one, and I know you guys may know what 12 divided by 3 is. That's okay. But we look, and we start with the number farthest to the left. How many times does 3 go into the 1? It doesn't, right? It doesn't go into it, certainly not evenly. Does 3 go into 12 then? Because now we're going to treat it like a 12. How many times does 3 go into 12? Well, we could look. 3, 6, 9, 12. I'm using my fingers to count those, by the way. Is that embarrassing to you guys? Like, what the heck is that? If it helps you guys out to use your fingers, do it, okay? Well, I counted 4, so 4 times 3 is 12. And when we take this away, we have 0 remaining. So 12 divided by 3 is 4. Well, over here we had 18 minus that stuff. And again, this may be helpful for you guys to see this vertically. So 18 minus 4. 8 minus 4 is 4. And then we'll just drop the 1. Bam, 14. So this comes out to 14. All right, again, no parentheses, no exponents. In this case, all we have is multiplication. Now, you guys may have seen multiplication as an x like this. We try to avoid using x's for multiplication because later on, x is going to become a letter, not a operation. All right, so from left to right, I've got 2 times 3. So 2 groups of 3 would be 3, 6. And then this, I've still got this 5 right here. Now I've got 6 groups of 5. 5s are pretty easy to count by. I like those. 5, 10, 15, 20, 25, 30. So when I combine these, I get 30. All right, here we don't have parentheses, but we do have exponents. So let's look at just the 3 squared on this thing. So that really would be 3 times 3. So 3 groups of 3, 3, 6, 9. And we see that 3 squared is 9. Of course, we still have that 2 times the 9. So we just drop the 2 there. Now I've got 2 groups of 9. 18. There you go. All right, let me ask you guys this then. What changes if we put parentheses around that 2?
It's the same.
It's the same thing. The thing about parentheses is that it starts the order of operations over again. So is there anything to operate inside that parentheses? No. So we just go back and we say, well, it's just 2, and then we'd multiply that by 3 squared. So here, in this set of parentheses, right now we're just going to focus on the parentheses. So we see that 6 minus 2. Just ignore that stuff for now, all right? So let's block it out of our minds because we don't need to see it. We don't need to think about it, okay? All we're going to do is focus on this set of parentheses. And we've got 8 minus 2 times 3. So there's no other parentheses in that parentheses. There's no exponents. But we do have this multiplication. So 2 times 3, 6. And now we've got 8 minus 6. Well, 8 minus 6, 2. Very good. That's 2. Well, now we do need to see what the heck was behind that stuff there. So the whole time it was still there, we just were ignoring it. So there is an operation between the 2 and the set of parentheses right here. It's multiplication. So if it helps you to see that, just draw it in there. Draw that multiplication in there if it helps you, okay? But it should help us to see that that's 2 groups of 2. It certainly is not the number 22, okay? So now we have multiplication from left to right, which is just this 2 and 2. 2 times 2 is 4. And now I've got 6 minus 4, which is 2. This one's a really good example because in this set of parentheses, we've got the exponent now, right? So again, ignore that 4. I'm not going to cover it this time. Hopefully we've got that down. We've got to evaluate what's inside that set of parentheses first. And inside that set of parentheses, we've got this subtraction, but before that, we're going to have to do this exponent stuff. So just making a note on the side here, I've got 4 squared, so 4 times 4, which is 16. So that's inside our parentheses. I've got 25 minus 16. Well, if you had 25 bucks and then someone took 16 bucks, how much would you have? 9 bucks, right? By the way, I still use my fingers on this kind of stuff. 24, 23, and then so forth, okay? But yeah, it would be 9. Now again, we do have this 4 in front. So this is 4 times the 9, and yes, if we want to, we can get rid of the parentheses now because we have just a number. So if I had 4 groups of 9, 4, 18, 27, 36. Bam. 4 times 9 is 36. All right, this is a fraction. Now the fraction line right here actually represents an operation, which is division. Very good. So this is really 10 squared divided by 2. But when it's shown like this, we've got to evaluate the numerator, which is the top, and then the denominator as well, until we have just a number, a value there. So right now we've got 10 squared, which isn't just a value. So we would have to solve what 10 squared is. So that's 10 times 10, which equals 100. Now again, we have that divided by 2. So we're ready to divide this, and yes, we can rewrite this as 100 divided by 2. That's better. But if we do this long division ways, we got 100 divided by 2. And 2 does not go into 1, but it will go into 10 5 times. 5 times 2 is 10. We'll subtract that out. And we've got 0. Well, 2 won't go into 0, but it will go, well, it won't go into 0 either, so 0. And that gives us 0 remaining. And so the answer to this one is 50. Sorry, that's a 0. So remember, we showed different types of parentheses here. And let's identify them. We got this bracket set of parentheses here in red now, which is a set of parentheses itself. So we got to look inside there. Again, we're ignoring that 4 that's in the front right here. But inside that set of parentheses, we got another set of parentheses now here in purple. So again, it restarts the order of operations. And really all we're doing is looking at this set of parentheses for now, okay? Yes, it does exist inside this set of parentheses, but we're ignoring everything else because this, by order, has to happen first. So, in this one, we have no other parentheses, no exponents. We just got that 8 times 6 minus 21, so we're going to have to do multiplication and division first, which we have multiplication. 8 times 6, so 8 groups of 6, 6, 12, 18, 24, 30, 36, 42, 48. And if that takes you a little bit longer, don't worry about that, okay? So I got 48 minus 21. So again, we're still focusing on this set of parentheses. I can do a little work here on the side, 48 minus 21. Again, if it helps you to see this vertically, 8 minus 1 is 7, 4 minus 2 is 2, and when we combine these, we get 27. Now, we didn't do anything with the rest of this stuff, so that 4 is still there. These square brackets are still here. And we've got a 3 plus 3. Well, now we're just looking inside this set of red parentheses, and yes, again, that's 3 times that 27, so we don't necessarily need those purple parentheses anymore. We do need the red ones, though. So, we'll do the multiplication before the addition. 3 times 27, this one may help to do vertically again. 3 times 7 is 21. 3 times 2 is 6, and then we add this 2 to get 8. So this would give us 81. And I've got 3 plus 81 inside the bracket parentheses and then multiplied by the 4. Now I can combine the 3 and the 81 to kind of finish off the parentheses. Yes, I'm keeping those expanded just so we can see it's the same set of brackets. 3 plus 81, I get 84. And of course this will be multiplied by 4. So over here I'll do the work. 84 times 4. Now notice over here it's 4 times 84. When we have multiplication, it doesn't matter which order it's in. So I like to see the bigger number on top when I multiply vertically. But it wouldn't matter if you did the 4 in the denominator either, or in the bottom part there. So when we do this again, 4 times 4, the 1's values. 4 times 4 is 16. I'll carry the 1 over into the 10s. 4 times 8 is 32, but then I add that 1 to get 33. So 4 times 84 appears to be 336. But again, if I had a calculator with me, I would check this. All of the stuff that I did there. 8 times 6. 48 minus 21, 3 times 27, 3 plus 81, 4 times 84. Okay? All right. Number 10 here, we've got that set of parentheses. Now, the exponent is associated with that parentheses, but since we've got to solve for the inside of the parentheses, again, we get ignored because it's on the outside, okay? Everything on the outside, it's like a storm out there. We're just going to ignore it until it breaks in. All right. So we got this set of parentheses. We can do 1 plus 3 first, which would be 4. And again, we've got this 3, the squared, and this plus 4. Now, a common mistake that I see on tests with these types of problems, it's good for you guys to know the common mistakes because I see it very often. 3 times 4 is 12. We can't do that. Can't do it, okay? What we have to do is square the 4 first. Because if we expanded this is what we would have. We would have 3 times, really this is 4 times 4 right here. See that? Now if we multiplied the 3 and 4 and then squared that, would get a much bigger number. Because now we're squaring a bigger number. So, let's look at that. That 4 squared, let's get rid of this garbage. 4 times 4 is 16. Which gets rid of that squared part of it, right? So I got 3 times 16, I'm just going to use the multiply, and then plus 4. Now we would multiply the 3 and 16, so yeah, we can do it like this, you guys. So 3 times 6 is 18, carry the 1. 1 times 3 is 3, but then add the 1 is 48. It's just a little weird to see it like this. It's not very normal, so 48. I'm not saying you can't do it, by the way. Just because I say it's weird doesn't mean that you can't. 48 plus 4 is 52.